Hello everyone. We'll talk about implant prosthetic steps in an easy and enjoyable way and solve side effects in this prosthodontics on Friday. I am Dr. Jo In-ho, the MC of the program. Today, this is the third lecture of Digital Spatial Lecture. Dr. Lee Soo-young is the lecturer. Before we start the lecture, would you briefly describe what you're going to say? There are 4 factors in digital dentistry, and I'm going to talk about the last item, 3D printing or milling. The characteristics and roles of each will be described. I look forward to your lecture. If you are watching on the dental site, you can ask questions using the chatting window on the right-hand side. The answers will be provided through the Q&A session. We will have a raffle draw, and 10 people will receive Starbucks coffee coupons if you're lucky. Please participate in the discussion actively. As I said before, I'm going to talk about the 3D printers and milling machines. This is the content. What is CAM? And I'm going to talk about the 3D printers first, followed by the milling machines. First, CAM. CAD is the word familiar to us. Through the computer, we do the design, so the word CAD is used quite a lot. And some people might not be familiar with the word CAM. CAM is the critical part to manufacture something. We don't stop at design. After designing something, we need to deliver something to the patient. So CAM is very important in the dentistry. It stands for computer-aided manufacturing. There are 2 parts there used in the dental offices. NC milling. Through numerical control, it is milled. In art, it is equivalent to sculpture. Out of marble block, using a chisel, beautiful sculpture can be made. And another thing is 3D printing or RP. These days, 3D printing is the more commonly used word. It is to do the modeling, creating something through build-up out of nothing. Like pottery, you create a pot through the pottery. In the dentistry, there are many restorations and appliances. To fabricate them, these 4 basic equipments are needed. Through milling machines and 3D printers, they can be fabricated. First, 3D printers. Talking about these 2 things in a short period of time, it's hard, so let me just go over the overview. This is the slide I used in the first lecture. 3D printer is relatively affordable in prices among the equipments of dentistry. It's easy to maintain. There are not many components. So in a dental clinic, the maintenance doesn't require a lot of efforts. Another advantage is that it can be used for multiple purposes. Using a 3D printer, we can do a lot of things. This is affordable and it is easy to maintain and it has high price performance. Dentures, temporaries, models, splints, surgical guides can be fabricated using various materials through one equipment. One equipment can be used and you can choose appropriate resin to create various appliances and restorations. Very good price performance. What is a 3D printer and what is it for? As you can see in the picture, 2D and 3D are different. 2D is two-dimensional, 3D, three-dimensional. How can that be used in real life? For 2D, a printer can be used such as an inkjet or laser printer. The output is something written on a piece of paper, so that is a 2D output. What about 3D printers? Three-dimensional objects can be created or printed, and there are different types of them, usually based on the size. The small one in 2D printers, on the left you have the small size personal printer, and on the right a big one used by businesses and schools for large volume printing. The same can go for the 3D printers. In dental clinics, we can use the personal printer and businesses can use the big printers. Osstem uses the big one to fabricate the surgical guides in the center. This is based on the size. And the second categorization is based on the types. 2D printers have laser versus inkjet. They do the similar work, but how they print is different. Laser and toner is used by the laser printer. Inkjet nozzle and ink are used by the inkjet printer. In the 3D printers, we have SLA and DLP types. They have different types. 3D printers, how do they print out objects? You may wonder. Let me give you time-lapse video, a very short one. It took about an hour to print that thing. However, it is condensed to about a minute, so it is playing very fast. The plate is going up and down continuously, and something at the bottom is created. I said a 3D printer is creating something out of nothing. There was nothing at the bottom, but now something is hanging at the bottom and the dental model is at each side. This is the principle of creating or printing. So at the bottom, there's a water tank with resin. Layer by layer, the material is deposited to print an object. There are two types. The first one is on the left, SLA type. On the right, DLP type. As you can see in the pictures, if you remember what you saw in the video just before, at the bottom, the orange one is the water tank. And if you look at the bottom, on the left, a laser is emitted, and on the right, a whole image is projected. SLA type uses laser beams. DLP, digital light processor, uses a projection of an image. So if you look at these pictures, on the left, the laser passes through the red dot. The resin is cured. And on the right, the square small pixels are projected. The light is projected. This is based on the light-cured resin. So UV light is used for both of them. This is very similar to the light-cured resin used in the dental office. At the bottom, in the water tanks, so this is the water tank, resin is there, and this is the platform. The model is created here. So it starts from here in the laser type. The dots, the red dots are irradiated, and in DLP, an image is projected layer by layer. The output product is the same from SLA and DLP. They are hanging below the platform. On the left, the SLA type laser should go through the plate. DLP, one image is projected on the whole layer. So, in terms of the speed, DLP is more faster, and SLA, it takes long time for each dot of light passes through the plate. So if you print out multiple models or appliances, DLP would be better. So depending on the purpose of use, you can choose SLA or DLP. Recently, actually, we had these two types in the mainstream, but now LCD type is emerging very strong. I believe you have this type of digital watches at home. The liquid crystal is used, and that is applied to the 3D printers in the LCD type. This is similar to what we saw before. This is the water tank, and below here, the light is irradiated. DLP had projection of image from below, but there's LCD panel right beneath the water tank. There is the LCD panel to determine whether light can pass there or not. If you look at it here, SLA type, the laser is cast, so special type, DLP, there's some light source at the bottom. An image is already determined when light is emitted from the light source with DLP, but with LCD, the image is not decided at the light source. It is decided at the liquid crystal, which determines which portion of the light would be passing through. Lately, the LCD type is adopted widely. These two are the 3D printers from Osstem. LCD type is on the right. They have merits and demerits, and it's difficult to talk about them in details. You may refer to this later after capturing it. DLP was launched in early last year. LCD was launched last month, very recently. DLP type is stable and it's a reliable machine, whereas LCD is easy to use and very low in price. Compared to DLP, LCD type is less than half of the price and it is small in size. It's handy. A surgical guide or temporary can be printed out fast in a local clinic. I purchased the LCD type 3D printer, the newly launched one. It is not installed yet, but I look forward to using it. Those three are the main types. Other than that, I hope you understand these two others, FDM, fuse deposition modeling, and the other one is the SLS, selective laser sintering. A metal object can be printed out by SLS type. FDM, when you go to a supermarket, you see a 3D printer printing out the figures or toys. A filament is rolled up using a nozzle. It is printed out. The nozzle has become finer, so the method has been stabilized it is not just printing out toys, it is very much used in the dental area as well. For your understanding, I took it from the YouTube. Houses are built with the cement or concrete. As it comes out, it is hardened. In China, actually, apartments are built like this. Compared to the past, FDM produced very coarse objects. The nozzle itself was thick and the technique was rough, so the whistle is printed out like in the left. It looks like a toy, but it is refined to produce something in the middle. Now, dental models can be printed out by this type without any problem. Very detailed output can be produced. And the other one is the metal printing SLS type. This is the RPD designing module by 3Shape. You don't need to use the investment technique like in the past. Laser passes through the cobalt chrome powder. It is melted and it is hardened. As the roller passes through, a layer is deposited. So layer by layer, it is deposited. After it is completed, cobalt chrome powder is dusted off. Then it is not casting, but using the 3D printing RPD framework is made. It looks rough, but after polishing, it looks decent. A decent RPD framework. The RPD framework that you receive from a lab, in many cases, are printed by the 3D printers. I talked about 5 3D printing types. In summary, it has very wide variety of clinical areas where it can be used, and the software supporting it is being rapidly developed. Also, the materials are being developed. At the beginning, we had 2 or 3 materials available for 3D printing. Now, a variety of resin products are on the market, and so many materials can be used for the printing. Printing is developing very rapidly also in the future. Therefore, more and more the printing can be used. This has been the 3D printing lecture. There are so many different types of 3D printing. Yes, for a beginner, what do we need to choose in terms of the type? There are many different types, but your purpose of use is important. If you treat orthodontic treatment and just want to print a model, it's different. But if you have a private clinic, you need to print out various restorations. The laser SLA type is a bit outdated these days. DLP and LCD are most widely used types. You need to choose one of them. For example, if you want to fabricate a temporary or surgical guide and apply it to a patient fast, then the recent LCD printer would be the appropriate one. It's also cheap, right? Yes, it's cheap. It'll be good. Looking at this, 3D printer seems to be used to fabricate a temporary prosthesis. So that's what I hear. What about the final prosthesis? 3D printer can create 2 things. One is the restorations that can be attached, and the other one is the appliance. Appliance can be a permanent prosthesis like RPD that should function in the mouth for a long time. If they can be considered a permanent final prosthesis, it can be printed out. But in terms of the restorations, temporaries can be fabricated with the printer. As in the last slide, the materials are being developed quite rapidly. In no distant future, actually zirconia printing is being tried by many companies, so that will be advanced rapidly, so final prosthesis can be printed out someday. With the development of the technology, maybe implants can be printed out by the printers someday, maybe not yet. It's too early now because the milling or mechanical or surface treatment would be the problem. Thank you very much for the answer, and you may continue with your presentation. Next, milling. As you can see, this is a beautiful sculpture. This is a sculpture rather than milling. To understand milling, we need to understand the concept of axis. As you may have heard, 4-axis, 5-axis milling machines. From how many axes the tool can access the object? If it is a plane, X and Y axis, and for 3-dimensional object, 3 axes, X, Y, and Z are needed. You can create a pyramid or something without undercut. You can print out with 3 axes. But in terms of a tooth, there is a contour and undercut. So for dental prosthesis, at least the 4 axes are necessary. Are there 6 or 7 axes? Yes, there are, but it is not cost-effective to have so many axes. So 4 axes is the most reasonable choice. We have only 2 milling machines used in the dentistry. This is the 4-axis milling unit, X, Y, Z. And here, this is the object to be milled. On the left and right, it can turn front to rear, and it can turn counterclockwise direction. So XYZ plus A or B, that's 4 axis. In the video, this is Osstem's 4-axis milling unit. The Emax block in purple color, it is being milled along the X and Y axis. The holder can turn in the clockwise or counterclockwise direction, so there are 4 axes. It is used for ceramics, ceramic block milling, inlay, onlay, ceramic crowns, or laminate. Ceramic materials can be milled with this. The characteristics of 4 axis, it is best for ceramic, and high temperature is needed for ceramic, so cooling system is required. Water spraying, wet type is used. Most materials can be milled, and this is specialized for ceramic milling. So ceramic zirconia PMMA can be milled. You may think 4-axis milling unit is less expensive than 5-axis milling unit because it has 1 more axis, but it's the opposite. 4-axis milling unit has more required components, so this is more expensive than 5-axis milling unit. 5-axis milling unit, XYZ, 3 axis, 3 dimensions, and we have 1 more, B axis, turning clockwise and counterclockwise direction, and A axis, turning back and forth. So 5 axis, X, Y, Z, and A and B. So this is the actual milling unit. There's a drill, moves in X, Y, and Z direction. This holder turns back and forth and clockwise and counterclockwise direction. In this video, this is Osstem's 5-axis unit advertisement. disc is used. It turns left to right and back and forth. So there are axes like that, X, Y, Z, A, and B. So precise prosthesis can be fabricated. Inside undercut can be fabricated. This is rather complicated, so let me skip over it. Inlay, onlay, crown, bridge, and hybrid prosthesis. Zirconia with gingiva can be fabricated. 5-axis unit, as I mentioned in the first lecture, there are many different materials available. It has been around for more than 20 years. That has been used by labs, and a lot of materials used by labs have been produced and supplied, and there are many material choices we can choose from. I didn't explain it accurately. The inside undercut can be fabricated, so it has very good fit, and multiple units can be fabricated at one time. 25 units. The discs can be fabricated. If you just design it and turn on the machine, on the next day when you come to work, multiple units are ready. There are so many material choices, and it is cheaper per unit. In terms of the 4-axis unit, they use a block, and the block is expensive. Discs are printed and supplied, so the unit price is much cheaper. A 5-axis unit has the bird changer, easy to use, and it's cheaper compared to the 4-axis unit, and it is robust. And in general, dry technique is used. Water spraying is not used. And the vacuum, using vacuum, the dust is suctioned out. 4-axis and 5-axis from Osstem are tabulated here. 4-axis versus 5-axis, wet versus dry, block versus disc. Indications: 4-axis unit is for ceramic. 5-axis is for zirconia and PMMA. It can also cover hybrid ceramic, combining resin and ceramic. So those are the indications for the milling. 5-axis unit is a bit bigger. So we can compare it like this. They look similar. 4-axis milling is like a sports car. 2 people can be in it, and it can run very fast. Ceramic can be made very beautifully. Emax, feldspathic porcelain, or laminate. Very beautiful output and very fast. 5-axis milling unit is very robust truck. A lot of materials can be loaded. It can work in very harsh environment. So in summary, milling units, it's the most expensive one among the basic equipments. It used to be intraoral scanner, which was the most expensive, but now it is in the middle price range. The milling machine is the most expensive one, and in terms of the maintenance, this is a little bit tricky to maintain compared to the 3D printers, but it is not really difficult to maintain. A little bit more attention needs to be paid to the maintenance compared to the 3D printers. 3D printers can be used for many different purposes. Even children's toys can be printed. If you download the figures on the internet, you can print the toys with the printer. The milling unit is expensive, so you cannot just buy it and try it. You will fail if you do that. You have to have a clear goal whether you are going to mill PMMA or others. So it is very expensive, and it is not good that you leave it idle. I talked about for about 30 minutes. 3 or 4 times a year, I deliver day lectures on digital dentistry. Tomorrow and the day after tomorrow, I'm going to talk about 3D printer one full day and milling unit one full day. And combining those two, I talked for a short time and it was I just skimmed through it. If you are interested in the subject and if you want to purchase the machines without failure, without making a mistake, come to my lecture next time. So with that said, let me finish my lecture. Thank you very much listening to your lecture. Milling machines have two different types. For a beginner, which one would you recommend? 4x versus 5x. 5x would be recommended. 4x, if you have one less axis, you may think it's easier to handle. For the 4x, you need to work properly. You need to provide the environment. But if you use the 5x unit, you don't really need to pay attention to the environment, and that can be compensated by the 5th axis. So 5 axis is easier to handle. And in terms of the available materials, 5 axis has so many materials that can be used, like 3D printers. You can use zirconia, PMMA, or hybrid ceramic. So I recommend the 5 axis. Thank you for the answer, Dr. Lee. Let's conclude the lecture by Dr. Lee. We have received questions in real time and let's deal with them. Dr. Lee, let's go to the real-time Q&A session. We have many questions received. So cool ID ask a question. Professor Joe and Dr. Lee, your faces glow with the brownish shine. You look wonderful. And where is the question? WKDIGTE. I don't know how to pronounce it, but the question is 3D printer or milling unit, which one should be purchased first for applying to digital dentistry? That's a very practical question. Of course, 3D printer is the answer. As I said before, milling unit, you have to have a clear goal, and you need to do something before you establish the goal. So to experience the digital, 3D printer is versatile. And if you think 3D printer is not for you, then the lesson fee is pretty low because 3D printer is much cheaper than the milling machine. So 3D printer is the starting point. And if you want to start with a low budget, LCD printer launched last month is very good. Osstem's LCD printer? Yes, thank you. In my view, if you are not interested, but still, digital dentistry is the future. I'm not sure whether it will be in 5 years' time or 10 years' time, and you need to get interested in the printer, right? Yes, if you buy a printer and you will get interested. Yes, dentists love creating something, right? Yes. Another question? Go ask the question. 3D printer or milling unit, is it difficult to manage them in a dental clinic? I'm not sure the point of the question. It depends on the point of the question. in terms of the equipment itself, it's not really difficult to manage. 3D printers does not need maintenance. Milling units requires a little bit of calibration. If the intention of the question is really about the operation of the equipment, you can use your staff, as I mentioned in the first lecture. For digital dentistry, the doctors, hygienists, and if you have in-house lab technicians should have clear responsibilities and roles. That is important. So you need to define that before you start. A doctor, if a doctor thinks if he purchases a milling unit, everything else will be taken care of by the staff, that will not work. It is something all parties need to get involved. So you can start with a 3D printer, which is not difficult. And if you reach a common sense of understanding, the next step would be the milling unit. So if it is a simple management of devices, you don't really need to be worried about that. Does that fail often? No. If it fails, you can call Osstem. So do they come to you fast? Yes. Just make a phone call. Big businesses provide very good after-sales services. The last one, the middle one, la. Everything should be done digitally these days. Starting now is not too late, right? One comedian said, when you think it's late, it's really late. Is it really late? If he or she thinks it's late, it's really late. So you need to get started as soon as possible. So first movers who moves first can occupy the area before others. So doing it even a day faster than others would be good for one's own pleasure. There are so many dental clinics. What you say is right, but if I look at my colleague or junior dentists, I try to get them on board the digital dentistry for one's own pleasure, to be satisfied with the dentist profession. It is something that gives you some pleasure of creation. So digital dentistry helps. So in a new world, you can get out of the boring practice. Yes, it enriches our profession. In the past, when implant was first introduced, before that, dentists did the endo treatment, did the amalgam work, but dentures are provided and patients would complain about it. That was the scope of work. After implantology, the sense of satisfaction in the profession of dentists has increased. So there is a paradigm shift with the digital dentistry. Definitely, implantology opened up a new opportunity for us. Thanks to the implant, Osstem emerged really strong in Korea and around the world. And Korea is renowned in the field of implantology because of Osstem in other implant companies in Korea. So what I'm saying is that we can have the second chance in the digital dentistry. So as a pioneer, I congratulate you on being the pioneer in this field. Thank you for the questions. I'd like to express my gratitude to those who participated in the real-time discussion. We will use lucky draw and select 10 of you to receive coffee coupons. This concludes the real-time Q&A session. Next time, you will have another digital special lecture. What is it going to be? So this will be the last lecture out of 5 in a series associated with the implant placement. The digital implant guide is used quite a lot. So the 4 basic factors will be utilized, how they can be related to the digital implant guide. That will be the 5th lecture next time. The representative product of digital system, the one guide, the digital guide, how to use it in a clinical setting. That's what you're going to talk about, and I look forward to your lecture. It'll be very interesting. Thank you. Thank you very much for being with us on the prosthodontics on Friday. How was it? The lecture by Dr. Lee. Easy explanation was given by Dr. Lee regarding 3D printing and the building units. The questions not answered will be commented online. Next time in the digital special lecture, Dr. Lee Soo-young will talk about the lecture again. Thank you very much for staying with us until the late hour. Thank you very much. I enjoyed your lecture, Dr. Lee.